Good morning, students. Today we will continue chapter 10 gravitation with the topic how is force of gravitation changed or affected when masses of objects are changed and distance between them is changed. First of all, we will see the change in the gravitational force between two objects when their masses are changed. According to universal law of gravitation, every object in this universe attracts other object with a gravitational force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let us consider that there are two objects A and B having masses capital M, small m, and both are at a distance of d. Now, according to universal law of gravitation, object A attracts object B with a gravitational force F, which is directly proportional, directly dependent on the product of their masses, that is m into m. It means if masses of both objects increase, then force between them also increases. If masses of both objects decrease, then force also decreases. So this is called direct proportionality, direct dependence. Gravitational force between two objects, it is directly dependent, it is directly proportional on the product of their masses. Means if masses increase, force also increase, and if it decrease, force also decreases. One more thing, if mass of any of one object increases, then also force increases. And if mass of any one of the objects decreases, then also force decreases. So overall, this gravitational force is directly proportional to the masses. So if masses of both objects get doubled, then product of masses will be 2m into 2m, 4m into m. Means now masses of both objects become 4 times than the previous one. So force is directly proportional to the product of the masses. So force also increases by 4 times. And if masses of both objects are reduced to half of the former value, half m into half m, then its product is 1 upon 4 m into m. So now product of the masses are reduced to 1 upon 4 of the previous value, then force is directly proportional to the product of the masses. It is also reduced to 1/4 of the former value. So this is the dependence of force on the masses of the objects. Now, if distance between them is changed, as I told you, according to universal law of gravitation, every object in this universe attracts other object with a gravitational force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. It means this gravitational force has inverse dependence, has inverse relationship with the square of the distance between them. It means if distance increases, then force decreases. If distance decreases, force increases. It is obvious that if you make both the objects to come closer, their gravitational force will be increased. And if you will make both objects to go farther, then gravitational force between them is reduced. So, distance decreases, gravitational force increases. Distance increases, gravitational force decreases. So, this is the dependence of gravitational force on the distance between the two objects. If distance between the two objects is doubled than the previous value, previously it was d, now it's 2d, then force is inversely proportional to the square of the distance between them. So now distance is 2d, its square is 4d square. It means force becomes 1 upon 4th of its previous former value. And if distance between them is reduced to half, then initially distance was d, now it is half d. Then force is inversely proportional to the square of the distance between them. So F is inversely proportional to square of the distance between them. Distance is half d, its square 1 upon 4d square. Then force is 1 upon 4d square, it's 4d square. Means now force is 4 times than the former value. So in this way, if you reduce the distance, like here, force increases. If you increase the distance, force decreases. So in this way, force of gravitation changes when masses of the objects and distance between them change. Now, next topic is free fall. When an object is released from a certain height, then it falls or moves towards Earth under the influence of gravitational force only. This kind of object is said to be in free fall or is known as freely falling object. Look at this marker. This marker is kept at a certain height from the ground or Earth's surface. Now, when it is released from this certain height, obviously it will fall or move towards Earth or ground. Why? Because it is under the influence of gravitational force only. So, this kind of object is said to be in free fall or is also known as a freely falling object. So when any object is released from a certain height, then it falls or moves towards Earth under the influence of gravitational force only. That object is said to be in free fall or is also known as a freely falling object. This kind of freely falling object undergoes or experiences an acceleration by the gravitational force of Earth, known as acceleration due to gravity, which is denoted with small g. Simply, acceleration is denoted with small a, which we already studied in chapter 8 and 9. But here we are talking about acceleration produced due to the gravitational force of Earth. So this is a special kind of acceleration known as acceleration due to gravity, denoted with small g in place of small a. And on Earth, acceleration due to gravity, which is denoted with small g, has a constant value of 9.8 meter per second square. How is this value derived or calculated? That I am going to tell you. Consider an object having mass small m, which is kept at a certain height from ground or earth's surface. Now, when this object is made to fall from this certain height, obviously it falls or moves towards ground or earth's surface under the influence of gravitational force of earth. So this object is said to be in free fall, or this object is also known as a freely falling object. Now, this freely falling object experiences an acceleration produced by the gravitational force of earth, known as acceleration due to gravity, which is denoted with small g, has a constant value of 9.8 meter per second square on earth. This freely falling object experiences a gravitational force. So the formula of gravitational force is equal to Gm into m upon r square. This is the first step. As this freely falling object experiences a gravitational force F, which is equal to Gm into m upon r square. Now you are thinking that previously I told you gravitational force is equal to Gm into m upon d square. Now I have replaced this d with r. Why? Because if the gravitational force is acted between two celestial or heavenly bodies like earth and sun, then we apply this formula of gravitational force, that is F is equal to Gm into m upon d square, where G stands for gravitational constant, capital M stands for mass of first object, into small m stands for mass of second object, upon d stands for distance between them square. But if the gravitational force is acted between an object on the surface of earth and earth, then we apply the formula F is equal to Gm into m upon r square, where capital G stands for same universal gravitation constant or gravitational constant, capital M stands for mass of first object, that is mass of earth, into small m stands for mass of second object, that is mass of this object, upon r square, this is the radius of the earth square. Now gravitational force is a kind of force, and we know that formula of force is equal to ma, F is equal to ma. This is second step. Now here freely falling object undergoes an acceleration due to gravity. So it is not a simple kind of acceleration, it is acceleration due to gravity. So in place of A we write G. Now F is equal to Gm into m upon r square. This is the first step. F is equal to mg. So both these sides are also equal to each other. So on equating both steps, we get Gm into m upon r square is equal to mg. This is third step. Now cancel m by m. We get Gm upon r square is equal to g. So what is the formula of G, acceleration due to gravity? It is Gm upon r square, gravitational constant into mass of earth upon radius of earth square. Now on putting the values of G, M and r square, we get the value of small g. Now put the values of Gm upon r square. Capital G means gravitational constant. It has a constant value of 6.673 into 10 to the power minus 11 Newton meter square upon kg square. So In round of figures, we write 6.673 as 6.67 into 10 to the power minus 11 Newton meter square upon kg square into mass of earth. It is 6 into 10 to the power 24 kilogram upon radius of the earth, that is 6.4 into 10 to the power 6 meter square. Now when you solve it, you will get the value of small g, that is 9.8. And what about its SI unit? See, meter square is cut with this meter square. Kilogram will be cancelled by 1 kilogram. Now you have small g is equal to 9.8 Newton upon kilogram. 9.8 Newton. In chapter 9 you studied what is Newton. It is kilogram meter per second square upon kilogram. Cancel kilogram by kilogram. Now what have you got? 9.8 meter per second square. So this is the constant value of small g, means acceleration due to gravity, that is 9.8 meter per second square on earth. Now is this value constant on all over earth? No, not at all, because earth is not a perfect sphere. It is not perfectly spherical in shape. It is longer at the equator and shorter at the poles. So radius at the equator is more than the radius at the poles. Then how does it affect the value of small g? It affects because as you have seen that small g is equal to gm upon r square. Acceleration due to gravity is equal to gravitational constant into mass of the earth upon radius of the earth square. We know that this capital G means gravitational constant. It is an universal gravitation constant which has a constant value of 6.673 into 10 to the power minus 11 Newton meter square upon kg square in whole universe. So it is constant for whole universe. And mass of the earth, it also does not change, so it is also constant. So both these quantities are constant. So if these quantities are constant, then what is the relationship between g and r square? G has inverse relationship with square of the radius. Means acceleration due to gravity, that is small g, is inversely proportional to the square of the radius of earth. It means if radius of earth increases, g decreases. If radius of earth decreases, g increases. And just now I told you that earth is not a perfect sphere. Its radius at all over the points are not same. At equator, its radius is more. So acceleration due to gravity, small g value is less at the equator. And radius at the pole is less. So value of acceleration due to gravity is more at the poles. So in this way, this value of acceleration due to gravity, small g, varies at equator and at poles. Otherwise, this acceleration due to gravity, small g, holds a constant value, that is 9.8 meter per second square at rest of the parts of the earth, but it varies at equator and at poles. It increases at poles due to less radius and it decreases at equator due to more radius. Now next topic, mass and weight. There is a misconception regarding mass and weight. Many of the people think that mass and weight are same. They take mass and weight in same sense. But they are quite different from each other. How's that? Mass is determined by the total content or amount present in the body. So, mass is determined by the total content or amount present in the body. So, whatever the content or amount present in our body, that decides our mass. And we all know that this content or amount in our body does not change from place to place. So, it remains constant. Mass is denoted with small m and its SI unit is kilogram. Whereas weight is the gravitational force by which object is attracted. So what is weight of an object? It is the gravitational force by which object is attracted. For example, what is the weight of an object on the surface of earth? It is the gravitational force by which it is attracted towards earth. Or I can say that it is the gravitational force which is exerted by earth on that object. Now what is the weight of the object on the surface of moon? It is the gravitational force by which object is attracted towards moon. Or I can say that it is the gravitational force which is exerted by moon on that object. So, weight is the gravitational force by which object is attracted, or it is the gravitational force which is exerted on the object. So, if object is on the surface of earth, then earth exerts more gravitational force on that object as compared to that of moon, because earth has more mass. So, earth applies more gravitational force on the object. Because I told you initially that according to universal law of gravitation, gravitational force is directly proportional to the product of the masses of objects. So, earth having more mass, so its gravitational force will be more on the object as compared to that of moon. And moon has less mass, so its gravitational force on the object is less. So, that object is attracted with more gravitational force on earth. So, its weight is more on earth. And on the surface of moon, it is attracted with less gravitational force by moon. So, it has less weight on moon. So, weight varies or changes from location to location. It does not remain constant. It is denoted with capital W, and weight is the gravitational force. So, it is a kind of force. So, its SI unit is Newton. Now, next topic. Let us consider that there is an object having mass m. which is kept on the ground. Now it is raised to a certain height h. When you raise this object to a certain height h, then you need to apply force on it so that it can be raised to a certain height. How much force do you apply on it? Equal to its weight. So, weight is equal to force. This is first step. Now, in 9th chapter we studied the formula of force, that is F is equal to ma. Second step. Now here acceleration is produced due to gravity. So A is replaced with small g. So F is equal to mg. Now W is equal to F and F is equal to mg. So on equating both the equations, or I can say that W is equal to, substitute this F with mg. We have this equation, W is equal to mg. So this is the formula of weight is equal to mg. Now as you know that this small g, acceleration due to gravity, has a constant value of 9.8 meter per second square on earth. So this g is constant. Then what is the relationship between weight and mass? If mass is more, weight is more. If mass is less, weight is less. And it is obvious, because if mass is more, then it is multiplied with constant value of g will result in more weight. And if mass is less, then it will multiply with the same constant value of g will result in less weight. So if mass of any of the object is more, then its weight is also more, and if mass is less, then weight will also be less. Weight is directly proportional to the mass of the object. Okay. Now there is one more formula of weight, that is W is equal to Gm into m upon r square. How is that? Because as I told you, weight is the gravitational force by which object is attracted. So weight is the gravitational force. Weight is equal to gravitational force. Then weight is equal to, what is the formula of gravitational force? This is Gm into m upon r square. Okay. So this is about mass and weight. As you have learned previously that if object is on the surface of earth, then earth exerts more gravitational force on the object due to more mass. So the weight of the object on the surface of earth is more as compared to that of moon. And if object is on the surface of moon, then moon obviously exerts less gravitational force due to less mass. So the weight of the object is less on the surface of moon. So when object moves from earth to moon, its weight is reduced. Now we want to calculate up to how much extent it is reduced. That I am going to calculate. We will calculate weight of the object on the surface of earth, denoted with capital W small e. So this stands for weight of the object on the surface of earth is equal to gravitational force. And what do you mean by gravitational force? It is Gm into m upon r square, because weight is equal to gravitational force. So here I have replaced that gravitational force with its formula Gm into m upon r square. G stands for gravitational constant, capital M stands for mass of earth. So I am writing me for mass of earth. Small m is the mass of the object upon radius of the earth, re square. So this is weight of the object on the surface of earth. Now weight of the same object on the surface of moon, Wm, is equal to gravitational force of moon on that object. So weight is equal to gravitational force. This force is substituted with Gm into m upon r square. Weight of the object on the surface of moon is equal to G, gravitational constant, capital M. Here capital M means mass of the moon. So I am writing capital M, small m. And this small m stands for mass of the object upon radius of the moon Rm square. So this is weight of the object on the surface of moon. Now we take their ratios. So now I have taken the ratio of weight of the object on the surface of earth to the weight of the object on the surface of moon. That is Gm into m upon r square upon Gm into m upon r square. Here I have written me, re, mm, rm in order to distinguish, in order to differentiate that this is the mass of earth, mass of moon, radius of earth, radius of moon. Now cancel capital G with capital G because both have same constant value. Cancel small m with small m because this stands for mass of the object, that is also constant. Now what is there? We upon Wm is equal to Me means mass of earth, that is 5.98 into 10 to the power 24 kilogram. In round of figure we can write 6 into 10 to the power 24 kilogram, which we have written previously, upon radius of the earth, that is 6.37 into 10 to the power 6. Previously I have written its rounded off form, that is 6.4 into 10 to the power 6 square divided by, this divide sign is replaced with sign of multiplication. Now reciprocate this, then Rm square, Rm 1.74 into 10 to the power 6 square upon mass of moon, that is 7.36 into 10 to the power 22. When you will solve this, you will get We upon Wm is equal to 6. So when you will calculate it, when you will solve it, its value will be around 6. Now transfer Wm from left side to right side. Here it is in denominator side, here it will come in numerator side, and transfer 6 from right to left side, so it will come in denominator side from numerator. Now we have We upon 6 is equal to Wm, means weight of the object on the surface of moon is 1/6 of the weight of the object on the surface of earth. Means whatever the weight of the object on the surface of earth, that becomes 1/6 on the surface of the moon. So up to this extent, weight of the object reduces on the surface of moon. It becomes 1/6 of the weight of the object on the surface of earth. Means whatever the weight of the object on the surface of earth, that becomes 1/6 when the object is on the surface of moon. So if weight of the object on the surface of earth is 60 Newton, then it becomes 1/6 of it. and Wm is equal to 60 upon 6, that is 10 Newton. So up to this extent, weight of the object on the surface of moon is reduced. This is all for today. Thank you. Have a nice day.